Hello, ma'am. Hello. Hello, ma'am. वो doubt भेजा. I sent a doubt. Two doubts.
Hmm. Okay.
Hello. Hello.
Are you able to hear me?
Now, ma'am, I could.
Hmm. Yeah, I'm just seeing the
Ma'am,
doubts.
I have sent two doubts. You can take together and you can compare how to solve because they are. I think they are same type of questions, but methods are applied differently. You can take up both side by side.
From where you have taken this question?
Ma'am, this is from one is from tutorial video and the other is from activity portion of week 8.
Hmm. You're not able to solve it or something else?
Ma'am, that tutorial one I was not able to understand and the means I have sent you two questions. I think they are of same approach, but different approaches are implemented there.
Yeah. No, I'm just. So, what's your doubt in this? Like, you're not able to implement, or
Ma'am, you could please share the screen, then I could explain you what's the.
sh to show you the question?
Yes, ma'am, both one.
Hmm. Good. See, like I would be doing the first question, that maybe the activity, the first
Ma'am,
question.
ma'am, what's the main doubt I have is the first question, the activity one. Here we are adding the individual events like the shoe and plus the shoe's probability is 0.6, right?
Huh.
Ma'am, and Rohan probability is 0.7. So we are adding here and then dividing by the total probability. Whereas in the tutorial video, the sir taught us that the complement of both the event should be multiplied. But I think they can also be added and we can take the total probability in the division process.
Um,
Ma'am,
Okay, so according to the question, it is given in a badminton practice session, the probability that the shoe serves properly is 0.6. So
mhm.
let's suppose, like, uh, question is that it is served properly. So let's suppose I am taking an event E, like they serve
Mhm.
properly. Fine.
Yes.
Okay. I need to find out probability of E, correct?
Yes.
Now in this, it is stating that Dishu plays the game is 0.5 and probability that who's the other person? Rohan. Rohan plays the game is 0.5, correct? They have
Mm,
equal chance to uh,
yes,
play
ma'am.
the game, correct? Badminton. Now, now it is being said that probability that given that Dishu played, he served properly. It is 0.6, correct?
And why don't they have a 1-1 chances?
1-1 chance with that.
Means probability of Rohan, probability of Dishu.
Huh,
Why they
the
are
probability of
0.5?
Dishu is 0.5 and probability of R is 0.5
Why?
because they are equally likely, na? And we have only two. Okay, for a uniform, we have two numbers, 1 and 2, and they have equal chance. So
Mm,
what is the probability of occurrence of 1?
yes, 0.5.
0.5, correct? So that is
Mm,
the same thing. So this is Disha and this is Rohan. So they have equal chance of playing the game. So what is the probability of playing for playing Disha? 0.5?
0.5.
Huh,
Right.
that's it. So this will be 0.7. So you need to find out probability of E. Oh, sorry, this will be E. So what is E? E would be probability of D into probability of E by D plus probability of R into probability of E by R. That's it. Okay. Understood the question?
Ma'am, could you please explain probability of E, how you have written like this?
See, we
Why
need to
they're
find
both,
out.
ma'am, why they are both adding? This is the main issue.
This is law of total probability, now. Do you know what is law of total probability? If I'm having, let's suppose I'm having two events, A and B, then
Hmm.
probability of uh, A will be probability of B into probability of A given B plus probability of B complement into probability of A given B complement, right? So basically my probability of A is what? The weighted average of the conditional probability of A given B plus the weighted average of the conditional probability of probability of A given B complement. So that is, so we are just taking the cases in which, like, what are the cases? Law of total, like, what is the probability that a total occurrence of A? So what we will be doing, probability of B into A given B, then we will be taking the another condition in which B is complement. So similarly, we have what are the events? We have these are my events. Okay. One event is this one, this is my E1, and this is my E2, right? This is my events. So I am taking E as they are serving properly. So I need to find out probability of E that they serve properly. So what are the conditions? The first condition is like Divya plays, and what is the probability if Divya plays that she serves properly. Plus
Rohan.
Rohan. Rohan plays into the probability that Rohan plays very well. Rohan plays and he serves properly. So these are my conditions. So I would be adding all the conditions to find out the
Ma'am,
to
there could not be one condition where both of them are serving properly.
so I am taking the condition na, that they are serving properly.
No, you are taking the shoe has served and then Rohan. But what if both of them are serving properly?
No, we can't take them. We will be taking the individual thing. Okay.
Ma'am,
So
I'm getting confused between total probability and Bayes theorem. Because in conditional probability they give they give mostly they give given that, so that's the indicator of conditional probability, but what's the indicator of total probability?
what Were you there at tomorrow's, yesterday's live session?
No, ma'am.
No. Have you gone through the lecture video?
No,
No.
no, ma'am.
Um, just do one thing. Just go
Mm,
through the lecture videos. Just go through the recordings of yesterday lecture. Okay,
mm,
live session. Just go
yes.
through that, and then you just understand that thing. Then you will come to know the difference. Okay.
Okay, ma'am. You have summarized week 8 or what in the
Yeah.
previous
We
lecture?
did. Hmm.
Ma'am, and the second doubt you could take?
Right. Tutorial video. It's not there. Have you gone through the tutorial video?
Yes, ma'am.
Okay. Which tutorial it is?
First.
First.
Why they have just multiplied the complements?
Because just a second. Hmm. Please go to the book of the Bible, the Philippines, the effective percentage. Okay. Hmm.
Ma'am, here both are independent, right? Or the according to
Yeah,
the tutorial one.
yeah. So basically, they are independent, right? So we need to find out the defective disk not being detected, right? So if it's not manually being detected, it's 0.2, then electronically also 0.2. So not detected 0.3 into 0.2 into um, that, that one is a different condition, you can say. Okay, in the question, what it has been said, floppy disks go through a two-stage inspection procedure. Okay, each disk is checked for defects, first manually, then electronically. So first of all, first processes, there are two steps. Okay, this is first process, then the second process. In the first process, we check it manually. Okay, and in the second process, we check it electronically. Fine. Now, they have been saying that if the disk is defective, then a manual inspection will spot the defect with probability 0.7. So they are saying that in manual, we check for the defective and the probability is 0.7 when defect is there. Okay, so the probability for, so this will be like probability of checking the defect manually. Okay, now similarly, after the manual thing. So I'm just denoting this by E and this by M. Okay. So given that it has been checked manually, it electronically it detects the what do you want to say, the defect. It is 0.8. Correct? This is clear?
Yes.
Okay. So now they are asking what percentage of defective disk is not detected. So we need to find out probability that disk is not defective. That means D complement. Correct?
Yes.
है ना? Okay. So now first of all, so what will it be? D complement. That means it is not defected manually. Intersection, it is not even defected in electronic. Correct? Then only this will be the case.
Yes.
Okay. Now, if you remember, do you remember multiplication rule? Probability of A intersection B is what? Probability of
A into B.
A. No, no, no. If they are not independent,
P
multiplication
of
rule.
A, P of A into P
P
of
of
A given B.
you can P of B given A. Correct? So similarly, so this will be what? My probability of M complement into probability of E complement given M complement. So what is my M complement?
0.3.
0.3.
0.3 into what is probability of E complement given M complement?
0.02.
0.2, right? So this will be equal to 0.6. That's it. Understood?
Ma'am, yes, ma'am. Ma'am, I can say like that.
Hmm.
If this both the events are occurring consecutively, or both at the same time, you are saying. So we can apply here multiplication, and there both the events were not dependent on each other, like Deshu and Rohan.
This is
Means
dependent, right? After checking manually only, they are doing the electronic thing, no? So it's dependent, not independent.
ma'am, so here and condition is used, right?
What condition?
And is used, and there
Huh.
we can use or condition, because Deshu can serve, or Rohan can serve, but here the detection should be uh,
Both.
this manual thing should also not detect it, and electronic thing should also not
Huh.
detect it. That's why
Correct.
the final detection has came,
Yes.
defection has came, right?
Yes.
And there the Deshu and Rohan one, we have taken both for the separate event, means Deshu can also serve individually, or Rohan can also serve individually. And
Correct.
there was not like both should serve properly, then something happens,
Hmm.
right?
Yes.
Okay, ma'am, thank you.
Okay. And one more thing, have your peer thing solved? The peer review, your portal is working?
Yes, ma'am.
Mm.
Ma'am, tomorrow I have seen that one peer review was remaining. Yesterday I seen. Sorry.
Okay, okay. Fine. Okay, so your doubts are clear, should be? Any other doubt?
No, ma'am, thank you.
Okay.
Ma'am, one thing I have to ask.
Mm.
Means I cannot understand means whole properly, like total probability, but uh, this thing what I have explained to you, I was thinking this I understood, this approach of getting how and or, so is it okay? Means on the questions I can apply this approach.
Yeah, you can do that, but just read the question carefully and what they are asking and all. You have to just do some practice more, I guess. Like if you're doing this approach and all, you should be knowing what you are doing. So I think you should do more, some more questions, then only you will understand it more better. Just go through the lecture once.
Yes.
I would. recommend that too.
Previous lecture of yours, right?
Yeah, mine or ma'am's lecture or any, like,
Hmm.
because you just go through the lecture and then do the questions, then you will be able to understand it more clearly. Okay?
Okay, ma'am. I think tomorrow, yesterday you conducted the mock two quiz one for quiz two.
Then,
No, okay, okay, ma'am. Thank you.
mm, yes, Suraj.
Hello, good evening, ma'am.
Good evening.
Ma'am, I have a doubt in conditional probability.
Hmm.
Uh, Ma'am, when it is given, ma'am, I am asking my question by taking an example.
Hmm.
So we have 52 playing cards, and we need to select two cards. So
Hmm.
at first we have selected ace of club, and then we need to select a diamond. So here is a given condition is we have selected our first card, which is ace of club, and now I need to select a diamond. So it is means probability of d given that first card is selected. So
Hmm.
it would be equal to probability of intersection of the both conditions
Ah,
upon our last condition, sorry,
correct.
first condition.
First condition.
So, ma'am, we need to solve this question. So, how to take this intersection part in mathematical terms? So, ma'am, I'm getting stuck in this thing when I am solving questions.
Conditional one, right? Just a
Yes, ma'am.
second.
So, and ma'am, one question I have shared here in chat box. So, similar thing is there. Means I am,
Similar thing.
ma'am has, yes, ma'am, in this question, in chat box. And uh, at first which I have discussed right now, uh, that,
Okay, so basically we can see this one, right? This question, the first question.
ma'am, it is from activity 8.3.
This is activity 8.3. So this is the conditional thing, na? So what is it?
Yes,
It has been asking, like, two fair dice are used. What is the conditional probability that at least one of the dice lands on 5, given that the sum is 11? Okay. So there are two events, A and B. What is A? At least one of the die lands on 5, and B is sum is 11. Correct? I have two events, right?
yes, ma'am.
Okay. So what I need to find out? Probability that at least one of the die lands on 5, given that the sum is 11. That is
Yes,
A
ma'am.
given B.
Yes, ma'am.
Now, so it will be probability of A intersection B divided by probability of B, right?
So, ma'am, here this how are we taking this intersection 2 by 36? That,
Okay. So first of all, what is my A? That at least one of the die lands on 5, correct? So that
yes,
means, okay, so if I'm having two fair dices, right? So
yes, ma'am.
how will my outcome will look? My outcome will
Five
look
one,
like,
5 2, 5 3, 5 4, 5
so
5
it will be
5
5
6,
comma 1, 5 comma 2 till 5 comma
comma
6,
6.
like that, right? So, and
Yes, ma'am.
they are saying that in any of the dice, so I can have 6 comma 5 as well,
Yes, ma'am.
right? I can have 4 comma 5 as well. I can have
Yes,
5 comma 5,
yes, ma'am.
something kind of like that, right? Now they are saying that, now what is my A is like at least one of the die lands on 5, and B sum is 11. So just join the both of the condition. So my one condition would be at least one of the dice should land on 5 and the sum should be 11. So how this will happen? This will happen only with two conditions, 6 by
Yes, ma'am.
5
5
and 5
6
by
6
6.
5.
So that's why we have the probability 2 by 36. Okay.
Okay, ma'am.
Like that, you have to
Yes,
solve the question. Okay.
yes, ma'am.
Hmm.
Okay, ma'am. So, ma'am, now I am skipping that question which I discussed, but I am asking this one which I have shared on chat box.
Okay, that one I've already discussed.
Ma'am, I would means no, ma'am. That one, Chirag, ma'am, which have there are two
Yeah,
questions in chat box.
There are two questions.
Yes. And one which I have shared.
Yeah, you have shared me this one, na? The card one, right?
Yes, ma'am, card.
That I've already discussed yesterday only.
Okay, ma'am, I am not asking full explanation. I am just asking that written in blue probability of E2 given that even has occurred is equal to probability of even intersection E2. So, ma'am, here this even is the ace of spades is in any of the piles, and E2 is the ace of spade and the ace of heart are in different
Different
piles.
pile,
So,
correct.
ma'am, yes, ma'am. How would we take intersection? I am understanding that part when I am subtracting 1 minus 12 upon 51. That is
So,
fine. But ma'am, how to solve uh, by taking intersection?
okay. So basically what they are saying, I'm having four piles, correct? So in the
Yes,
first
ma'am.
pile, I should have 13 cards, second in 13, third 13, and fourth 13, correct? In that,
Yes,
in
ma'am.
each of these piles, one ace should be different, correct? Now,
Yes,
I need to find out probability of E. So this is my E1, this is my E2, this is my E3, and this is my E4. Okay. So what is
yes,
my
ma'am.
probability of E1? Probability of even that spade is in the first pile. So that is a sure event. So I have taken it as 1. So probability will be 1.
Yes, ma'am.
Okay. Now what is probability of E2? That given that in my first pile I have spade, in the second pile I would be having the diamond. Correct?
Yes, ma'am.
Hmm. So now, so the probability of having diamond in the second pile, given that in the first pile I have spade, so this would be what? Um, so just take the condition as it is. Like in the first pile, so I have a first pile. In the first pile, I'm having spade. So so out of 13, one card is already fixed. That is ace, correct? Spade of ace. So remaining
Yes,
12
ma'am.
cards I have to select for the first pile.
Ma'am, what am I understanding here? Because we have selected those two, means second is in the second pile, and I only need to select those 24 cards. Sorry, ma'am, here 12, only 12
Only
cards.
12. Huh.
Yes, ma'am. So remain because there is a probability of event one is one, so remaining probability is of intersection. Ma'am, it is like this.
Huh, correct.
Oh, yes.
Okay.
Oh,
So
because
you need
here,
to find out.
hmm,
Huh. That is what you have to. Okay. So basically just take
okay,
the
ma'am.
conditions only. This thing.
Hmm.
Practically like how it is possible. That's it. Okay. These type of questions won't come. Just don't worry about it. Okay.
Oh, okay, ma'am.
Hmm.
Thank you,
Ma'am, I
ma'am.
have a doubt. Ma'am, I have a doubt from weeks 8.6 activity.
Week 8, 8.6.
First question.
Amir, New Delhi resident. This is the question, right?
Can you repeat?
First question is a male New Delhi resident is randomly selected,
Yeah,
right?
yeah, yeah. Yes, yes, yes.
Okay. Which of the following pairs of event A and B can reasonably be assumed to be independent? He is a doctor, he has brown eyes. He has a body pain, he was in accident. He is wearing blue shoe, he used to pay copy. Okay, so what are the pairs like which are independent? What do you think? What's it out in this?
Why can't be option P is also correct?
Option?
Can you explain the option B alone? Why it is not
Option?
independent in
Which
that
option?
case?
Which option? I'm not
Second
able.
option,
Second
B,
option.
B.
Okay, so
Yeah.
so they are saying that A is he has body pain. Okay. B is saying that he was in accident yesterday. So he had an accident. So after the accident, so they are related, right? So how I'm getting the body pain? They are saying, so first person is saying he's having body pain. The second person is saying that he had an accident. So okay, it is relatable. The situation is relatable, right? Because of the accident only, he is having the body pain, right?
Yes.
That's why they are not independent. Okay?
Okay.
Okay. Anything else?
Ma'am, I actually asked a doubt yesterday about the blocked roads.
I've gone through that. Okay, I will share you that. Okay, you can see this thing, right?
Yes, ma'am.
Okay. So the question is, there are two roads, each connect A, B, and B and C, right? Each of the four roads get blocked with probability P independent of all other roads. So A and B blocked, the probability of blocking A and B is P. Similarly, for B and C, it is P. The third road is blocked, it is P, and first road is blocked, it is P. The probability is P for all the roads. Okay. Now, what is the probability that there is an open route from A to B? So A to B is the open route, given that there is no open route from A to C. So A to C is closed and A to B is open. So we have to find out that one. Okay. The question is clear. So we are taking events. So the first event would be the first road from A to B is blocked. Second road from A to B is blocked. Third road from B to C is blocked. And fourth from B to C is blocked. Okay. So these are my events. Now my F event is denoting that there is no open route from A to B, and E is there is no open route from A to C. These are some events. You understood this thing?
Yes, ma'am, kind of.
We are just taking all the events. What are the events that we have? Okay. Now it is said that each road gets blocked with probability P. So they are independent of all other. So probability of first road getting blocked is 1/4. Correct?
Yeah, out of four roads.
Huh. Similarly for P, E2 is also 1/2, 1/4. E3 is also 1/4, and E4 is 1/4. Correct?
Yes, ma'am.
Okay. Now. Now, probability of F complement, that is that it is not an open, it is open route. So F was that it was not open. So F complement would be that it is open, correct?
Yes.
So for it to be open, so what are the options? Either my road 1 should be open or road 2 is open, correct? For A to B.
Yes, ma'am.
For A to B, if you see here, for A to B, my road 1 is there and road 2 is there. So if they should be open, either 1 should be open or either 2 should be open, correct?
Yeah.
Yeah. So now either road 1 is open, that is E1 complement, union of E2 complement. True? Right?
Yes, ma'am.
What is even? Even was that the road 1 is blocked. So complement of it will be that it is not blocked. Correct?
Yeah.
Okay. Now, so E1 complement union E2 complement. So this will be E1 intersection E2 whole complement.
Yes, ma'am.
Okay. Now, this whole complement will be equal to 1 minus probability of E1 intersection E2.
Yes.
Okay. Now, these are independent, E1 and E2 are independent. So this will be 1 minus probability of E1 into probability of E2, correct?
Okay, ma'am.
So now the probability of F complement will be 1 minus P square, right?
How did 1 minus p square come? Is it because we're taking probability of E1 and E2 as p?
Sorry,
Like, how did 1 minus p square come? Is it
1
like
minus
because...
P because they are saying that so P was the probability, right? They said in the question, like what is it? Each four roads get blocked with probability P. right?
Okay.
So that's why they are taking probability of E1 is P and probability of E2 is also P. So this will be 1 minus P square.
Yes.
Huh. Now, so probability of F complement is 1 minus P square. So probability of F will be 1 minus probability of F complement, which is P square. That's fine. So P F is basically my A to B road is blocked. So that is P square. Correct?
Correct.
Okay. Is
It's
this
more
fine?
understood.
Now, so probability of E given F, that means my A to B road is blocked. If A to B is blocked, then my B to C will also be blocked. Correct? What is my E? E is from A to C, correct? If my A to B road is blocked, so how can I go to C, correct? So that means my E given F will be 1.
Yes, ma'am.
You're able to understand the question?
Yeah, kind of. I'm getting it here and there, but yeah, I can
Yeah,
understand what
but
you're explaining.
this will take time
Will
actually.
these type of questions be asked for
No,
quiz too?
no. Where did you find
Because
this question?
this is from the ebook of statistics.
Oh, these kind of questions you won't be having.
Okay.
No. Now we are taking EF complement. Okay, so basically my road 3 and road 4 are blocked. So it will be E3 intersection E4, which will be P square. Then you need to find out probability of E. What is probability of E? That A to C road is blocked. So we will having the law of total probability. First of all, that the A to B is blocked. If A to B is blocked, then A to C is also blocked. Then the next condition, if A to B is not blocked, then what is the condition that A to C will be blocked? So we will be taking the two conditions, right? So we have just added that. Then we are taking out probability of F complement given E. So we need to find out this, right? The probability that there is an open route from A to B given that there is no open route from A to C. So E intersection F complement divided by probability of E. Then just solve it. That's it. These type of questions you won't be having.
And can you explain the E given F, that pattern?
P, this one.
Yeah, yes.
So okay. So what is my F? F is that there is no open route from A to B, correct?
Yes.
And E is there is no open route from A to C, right?
Okay.
Okay. So so PE given F is that what is the probability that there is no open route from A to C given that there is no open route from A to B?
So
Just
it is
think about
P
it.
by P.
Sorry.
It is P by P.
Huh. So this will be 1 only, right?
Okay.
Huh. So that means if my A to B is not open, so there would be no open route from A to C, correct?
Yes.
Yeah. So it's a sure event. So that means like probability will be 1. So that's why you can say it like that or like probability P by P is 1. You know, fine.
Yes. Good.
Uh, So and your doubt is clear?
Yes, ma'am.
Okay, fine.
Ma'am, I also have a doubt from few doubts from practice assignment week 8.
Back to you, Simon. What is the question?
Question number 15, 16, and 17.
Have you gone through the solution PDF?
Yes, I have.
Okay.
Can you like this briefly explain what is being done in that? Because there's like a lot of explanation, so I kind of didn't get it.
15.
15, 16, and 17.
Two dies of different colors. I think we'll suppose that it is
Ma'am, an unbiased coin or like a dice means it has equal probability, right?
Unbiased, right? Huh.
Yeah.
This question, right?
Yes, ma'am.
So A is the event that the sum is even, B is the event that sum is odd. So what are the chances that sample space for A is even? So these are the samples, and for B, these are the samples. Now, intersection would be zero only because A is the sum of even getting even and B is the sum of getting odd. So intersection, there would be no intersection, right? So they are mutually exclusive, correct? So my A and B are mutually exclusive, correct?
Yes. Understood.
Okay. Now, questions are there not independent, everything usually is positive. Okay. Now, since one of the die is biased and the other is unbiased,
So the red one is unbiased and blue one is biased.
yeah, so the blue one is biased, okay? So the first place is from biased and the second is from unbiased. So probability of 1 comma 1, 1 comma 3, 1 comma, so we are taking, so the this is 1 from the first dice and this is 1 from the second dice, correct? So I am having probability of 1 comma 1, 1 comma 3, 1 comma 5. So it will be what? 1 by 1 by 4, okay, into 1 by 6. 1 by probability of 1. So that's the point.
I'm like, what are we like multiplying this probability for?
One. Okay, understood. Okay, so we are taking this case. So probability of 1 comma 1. So probability of outcome of 1 is 1 by 4, correct? According to the blue die, right?
Yes.
Okay. Now probability of 1 according to the red die, this is a fair die, right? So if it's a fair die, so the outcome of coming out for outcome 1, 2, 3, 4. So what is the probability of 1? 1 by 6?
Yes, ma'am.
Right? So that's it. So probability of 1 comma 1 will be 1 by 4 into 1 by 6. Similarly, for 1 comma 3 will be 1 by 4 into 1 by 6 and 1 comma 5 will be 1 by 4 into 1 by 6. Fine?
I understood like the multiplication part, but why are we doing this? Like, for what reason? As in, like here we're multiplying for event A, which is the sum is even. So like 1 comma 1, 1 plus 1 means 2. So the sum is going to be an even
Okay, so
number.
basically we are checking out for the independency. So for the independency, what it is, probability of A intersection B should be equal to probability of A into probability of B, correct?
Yeah.
Yeah, so that's why they are first finding out probability of A, then they are finding out probability of B. Now, probability of A intersection B is 0 and probability of A into probability of B is not equal to 0. That means they are not independent. So B option is correct and option D is incorrect, right? You got it? You got the point? So they are taking all the cases. So first of all, they check for the mutual exclusive, mutually exclusive. So for that, they did that what is my A intersection B? Okay. So my A intersection B was the null element, that is 0. So that's why they are mutually exclusive. Then they checked for the independency. So what is the condition for independency? A intersection B is probability of A intersection B should be equal to probability of A into probability of B. Correct?
Yes, ma'am.
Hmm. So they are just checking all the conditions. That's why they found out the probability of A, then they found out the probability of B, and then they check the conditions like that. Understood?
Okay. Okay. So like for event A, we have to find the independency between A and B. All the outcomes we have to like do the multiplication rule, like
Then
independent
we have to
events.
check for the we have to calculate the sum of probabilities, right? So we have to check for probability of A. So what is probability of A? That the sum should be equal to the sum should be even, right? So what are the probabilities? So we have to add all the probabilities.
Okay. So the same thing we have to do for event B as well.
Correct.
Okay. And then we have to find the intersection if it's here the
Now,
intersection is it's like disjoint. So even if we
Hello.
multiply and we get
hmm,
a value, it won't be independent.
correct.
Hello.
Um, ma'am,
Hello, ma'am.
Just a second, just a second. Let Anne complete the thing. Yeah, Anne, you
ma'am,
complete.
so can we say that like all events A and B, for any events A and B, if they are like mutually exclusive, can we say that they are not independent
You can't
for
say
all
that. So
cases?
exclusive and independence are different thing, no?
Yeah.
So you can't say that if they're mutually exclusive, that means they're independent. You can't say that.
Okay. Can you do the other two questions as well?
16 and 17.
16. Yes, ma'am.
Okay, what's your doubt in this?
The same thing, like what method do we use here? Is it, I think we're using conditional probability.
Yeah, we are using the conditional probability.
Okay.
Yeah. Just go through the question and just search for what they are asking. So then you have to apply the formula only. That's it. Okay.
Hello.
Hello.
Okay.
Ma'am, the earlier question above 15 number.
Hmm.
This why it is 1/6
What?
here. Probability of 1 comma 1
Hmm.
equal to 1/4 into 1/6.
Yes.
Why it is 1/6?
The second die is a fair die, correct?
Sorry.
The second die, the red one,
Uh,
is a fair
uh,
one, right? Okay. So if it's an unbiased die, then what is the probability of 1 or 2 or 3 or 4, any of the 1 to 6? So what is the probability of the outcome of 1? 1/6?
coming 1.
Hmm.
Okay. Mm-hmm.
Okay.
Achha. And what is the meaning of biased dice and unbiased dice?
Unbiased means all the outcomes have an equal likely chance uh, of probability, and biased means they don't have equal chance of the probability. That means like if I'm having six numbers are there now in the dice, so
Yes.
outcome will be 1, the probability will be 1/6. So each and every outcome has an equal chance. So 1/6,
Oh,
1/6,
okay.
1/6. But in the bias, they don't have the equal chance.
Okay.
Okay. Yeah.
Okay. But ma'am, in the question, they have given the probability of 3 is 1/4,
Hmm.
right? In question.
Yes.
So, but you write here 1/6.
That is the 1 by For the 3, 1, 1 by 4, that is for the
Huh.
case for the first die. That is biased die, right?
Okay, okay. Okay.
Okay, and have you gone through the 16th question, the solution?
Yes, ma'am.
Yeah, now you understood?
Yeah, understood.
Okay. And what about the 17th?
I'm going through it. I
Yeah,
think
just
I
go.
understood as well.
Sorry?
I understood it as well.
Right. Yeah, just. Okay. Anything else? Lokesh, what's your doubt?
Ma'am, I have doubt one from graded assignment 7, question 11.
Graded assignment 7.
Question 11.
Have you gone through the PDF?
Yes, ma'am, I checked, but I didn't get it. How? I mean that after seeing the solution, I can solve the question, but after some time, when I try it again, I forgot how to do it.
These type of questions you won't be having in the exam, so don't worry about that.
Okay, ma'am, I have another doubt. I have sent question in the chat. Same problem with this question.
In the chat.
Yes, ma'am.
In a city, 1% of the floor test, 25% is 20% of the so this is, I think, base. This is the base rule, right?
Yes, ma'am.
Huh. So how you want to solve this thing? First of all, what are the values that you have been given? Just note it down. Okay.
Yes, ma'am.
I will tell you what, like, how to do it. The rest of it, you have to do it fine.
Okay.
Okay. So what is the question? You have been given that probability of in a city 1% people have swine flu. In the flu test, 95% of people with swine flu test positive, while 2% without the disease will test positive. Person is randomly chosen and test positive. What is the probability that the person actually has swine flu? Right. Now, so I am taking S as that the person has swine flu. Okay. So what is probability of a person having swine flu? It is 0.01. Correct?
Yes, ma'am.
So the probability that he doesn't have a swine flu is 0.
0.09.
It will be 0.9. Correct?
Yes, ma'am.
Now, it is saying that it has swine flu and it is being tested as positive. So this is probability 0.95.
Yes, ma'am.
Okay. And then they're saying that the person is not having a swine flu. Then also it is testing positive. It is 0.02. Correct?
Yes,
So what we have to find that the person is positive and he had given that he is positive, test the probability that he is the person have a swine flu. It will be S given positive, correct?
yes, ma'am.
So now this will can be written as probability of S into probability of divided by probability of positive, correct?
Yes.
Hmm. Fine.
Yes, ma'am.
So just solve this question. So probability of S is 0.01. Probability of plus given S, you have to find this value. And probability of plus, that means they are positive. So we will be taking the conditions. What are the conditions? Probability of into probability of S. Probability of plus given S complement into probability of S complement. Fine?
Yes, ma'am.
Understood the question? How to do it?
Yes, ma'am.
No. Anything else?
Ma'am, I am getting confused in law of total probability and multiplication rule.
Law of total probability and multiplication rule.
Ma'am, sometimes I think both of them are same and
How
get
are they
error in the
same?
question.
Law of total probability is a different thing and multiplication rule is a different thing. Multiplication is what? You're finding out the probability of, you're finding out probability of A intersection B. And law of total probability, you are finding out the probability of A. Probability of A, you are finding out with different conditions. Okay?
Okay.
Hmm.
Thank you, ma'am.
Okay. Saumal, yeah.
Yes, ma'am. Ma'am, I have a doubt in practice assignment 8, question 6.
Practice assignment 8, question 6.
Yeah.
Okay. Mm, 6. This is the question, right?
Yes.
Okay.
Ma'am, in the here
In the
I
question,
here I couldn't understand that how the probability of Abhishek given in the question is different from the probability asked.
probability given in the question, sorry.
I couldn't understand how the probability given in the question is different from the probability which is asked. I mean, the Abhishek's hitting is given, the probability of Abhishek hitting the dartboard.
Hmm. So
But it
basically
is,
what, see, the question they have been asking is, it is known that the target is hit by at least one of them. That means like Abhishek is hitting or Anu is hitting or both of them are hitting, correct? That is the, they are saying, right? At least one of them, correct? So that is A union B. So my A event is that Anu hits the target and B is Abhishek hits the target. So if they at least one of them hits, so that means A union, so I need to find out A union B means that at least one of them hits. Given that at least one of them hits, what is the probability that it is hit by Abhishek? So B given A union B. This thing is clear?
yes.
You had this doubt only, right?
Yeah, but
Huh.
as it is given that at least one of them hits the target,
Huh.
so shouldn't the probability of A union B be 1?
Why?
Because A union B means uh, at least one, yeah, Abhishek hit or Anu hits or both of them hits. So so
So A
one of
union
the
B would
three
be what?
events will
Probability of,
occur.
no, so A union, at least one of them, at least like Anu hits or Abhishek hits, or we can have a case in which they don't, so both of them they don't hit the target. So we can have that condition as well, right? So what is
But
A
it is,
union B? Probability of A plus probability of B minus probability of A intersection B, correct?
yes.
Yeah. So just Go through the formula.
But how can we have that both don't hit? Because in the question it is mentioned
We are
that at
subtracting
least one.
that thing, na? So A union B. A union B would be what? Probability of A. So if you just have a Venn diagram. So if you have a Venn diagram, so this is my A and this is B, correct? What this is? This is A intersection B, right?
Yes.
Okay. So I need to find out A union B. What is A union B? It will be A union means the whole. So my intersection should not be there, na? A union B. What it will be? Probability of A plus probability of B minus probability of A intersection B, correct?
Yes.
That is what they are doing.
Here A
Fine.
intersection B refers that both of them hit the target.
Sorry.
Here A intersection B refers that both of them hit the target.
Both of them hit the target, correct.
Okay.
Now we are about
Ma'am, can you solve question number 4 and 7 from activity 8.1?
activity.
8.7.
Uh-huh. What?
From activity 8.7,
Hmm.
can you solve question number 4 and 7?
8.7 question 4.
Yeah, 4 and 7.
4 and 7. A task is given to 3 students. If the program completing the task individually is more contended that the task is completed. The task is given to 3 students.
Are we like using the total?
Yeah, this is total probability only.
So like the probability of choosing one of the student would be like 1 by 3.
1 by 3.
And then we'll calculate the inverse. Yeah. So the 7th question.
Suppose that an IIT 40% are boys, it is known as 20% of the boys play cricket and 60% of the girls play cricket, while 40% play football and cricket. Given that 33% of those who play football also play cricket, a student is randomly chosen 1% that is student plays. Student is randomly chosen and he plays cricket. What is the point that the student plays football? The big 40% of 20% of the play cricket and 40% of the 40%
I tried the 4th question, and like I got 7 by 24, but the answer is 43 by 64. I tried it using the total probability, but I didn't get the correct answer.
I think I have to solve this question in just form. Can I just do this in the next session?
The seventh question?
Yeah, the seventh question. I have to solve it.
Okay, ma'am. And the fourth question, can you like solve it? Because using the total probability, I tried it, but then I got 7 by 24. But the answer is like 43 by 64. The given answer. Like, and I think we have to, there's some mistake or something.
But they're not saying that it's equal probability, right? The task is given if it complete the task in the okay. Fine. This is not the law of total probability actually.
So like, can you just solve the question?
Yeah, let's just suppose. So they are given the probability that the first one, let's suppose that A, the probability that first student completes the task is 1 by 2. Second student complete the task is 1 by 4. And probably the third student complete the task is 1 by 8, correct? So I need to find out the probability that the task is, find the probability that the task is completed. Okay, then find the point that the task is completed. Fine. Okay. So I can say that, so let's suppose that probability, yeah. So I can say, so they are completing the projects individually, correct? So I need to find out the problem that the task is completed. So first of all, if I have to find out the task is completed, I can calculate it by 1 minus the task is not completed, correct?
Yes.
Right? Okay. So if task is not completed, that means probability of A complement, which is 1 by 2. Probability of B complement, which is 3 by
3
4,
by 4.
and probability of C complement, which is 7 by
7
8,
by 8.
correct? So probably that task is not completed. So this will be what? 1 by 2 into 3 by 4 into 7 by 8, correct?
Between as independent events.
They
So
are
like
independent events, right? So this will be
Okay.
equal to 1. 6 ones are 21, 8 is 64, right? Now what is the task that it is completed? It will be 1 minus 21 by 64, which will be equal to 43
Yeah,
by
43. 43 was okay.
64.
Okay. Okay, ma'am, understood. So the seventh question. When is your next session?
No, next session. On Friday, I will be having the session. So on that day, we will just let you know.
Okay. One last question I put in the chat. It's from tutorial 5 of week 8. I've
Tutorial
posted
5.
the question. I've posted the question in the chat. You can maybe check in Sarut. I didn't understand.
The pair of unique natural functions for users is very simple. The unique functions for the it's rather like the original what 10,000 dollars Okay, I'll just do this in the next session. So two questions you have, right? So week 7, tutorial 5, and that 7. So in the next session, I will be doing that question. Fine?
Okay.
Just,
Thank you.
yeah. Right. Yeah, Tara, you have a doubt? The person who have raised,
Yes, I have a doubt in see my
your voice is not audible. Can you speak louder?
I have a doubt in see my group. Can I share my
Not able to hear you. Sorry.
Oh.
Hello? Sarah, I'm not able to hear. Can you just post your question in the chat box? Yes, you can share your screen. Sarah, are you sharing your screen?
mom? It's going off. It's allowing to share.
Okay, it's not allowing. Just a second. You can share the screen. Maybe there is an issue. But just try it once again.
No, ma'am, I can't.
What's your doubt?
How to
Huh?
August 20 about this question, ma'am.
Your voice is not audible. Your voice is breaking and it's very low.
Ma'am, do you have a session on Saturday or before Friday or like Sunday?
Saturday?
Oh no, I mean Saturday. Because I
No,
might not,
Saturday we don't have any sessions. Till Friday only we have session.
because I might not be able to attend Friday session. That's why.
Okay, just do one thing. Just
Or can I like you can maybe like email? Can I?
you can mail. Just mail
Okay.
the question.
Can
Then
you like post your email
um,
in the chat box or something?
August 24th, 15th question. What is this, Tara?
Man, can I ask doubt from week 6 practice assignment?
Yeah, you can. What's your doubt, Erin?
One minute, man. I have doubt from practice assignment week 6, 11th question.
Gone through the period?
Yes, ma'am, I am still doubting it. I cannot able to understand the solution.
Okay. Question 11.
Yeah.
What's your doubt in this?
I have doubt in the whole solution part.
The whole solution.
Voice is low.
No, I'm just okay. Okay. So first of all, the question is you the number of ways you can generate the username, right? So username contains 5 alphabets followed by 2 or 3 digits, correct? So for each of the alphabet, David has 26 choices and each digit has a 10 choices. Fine. So the total number of ways David can generate is 26 raised to the power 5 into the first digit having two choices, right? And similarly for 3 digit as well. So they are taking the condition. This thing is clear?
Yes, ma'am.
Okay. Now, now they're saying that David 343, he's using the username as 343. So how many ways he can generate this? So first of all, uh, so he cannot use DAVI in the password, right? Because in the
Yes.
question only it has been said that if the name has already been there, he cannot use that in the password, correct? That words.
Yes.
Hmm? Okay. So 4 words have been uh, subtracted. So in total, I'm having 22 choices for the 2 alphabets, correct?
Yeah.
Yeah. So in total, I'm having 22 into 22 ways, correct?
Yes.
Now, I need to have 5-digit odd number in the password such that the last digit should be larger than the second last digit and no digit should be 0. This is the condition.
Yes.
Okay. Now, so what are the number of odd numbers are 9, 7, 5, and 3, right?
Yes.
Hmm. Now, case one is when the digit unit place is having 9. Okay. So if the unit digit is having 9, so that is fixed. Okay. Now, 8 choices I'm having for the tens place, 9 choices for the hundred, thousands, and 10,000s place. Correct?
Yes.
Right?
Yes.
Yeah. Now, similarly, if I'm taking the seventh case, so in the tens, so in the ones place I'm having 7. So they are saying that the last digit should be greater than the other digits, right?
Yes.
Huh. So I'm having in total I would be having 6 choices for tens place.
How 6 choices?
Okay. So if I'm taking 7 as the units place, right? So 9 won't be there, 8 will not be there, and 7 will not be there. Correct? And
Yes.
7 has already been and 0 cannot be there as well. Correct? So in total, how many
Yes.
numbers have been left? 6 only, right?
Yes.
Hmm. Right?
So rest of the digits are been say like the same, right? 9 into
Yeah.
9.
So it will be 9 into 9. So in all of the cases, they are doing this condition. Then the unit space is 5. Then I'm having 4 choices in B. Then 3. Then I'm having 2 choices. Then just adding all of these numbers.
Okay.
Okay. Okay then. So anything else? Okay. So there is no more doubts. There are no more doubts. Shall we end the meet now?
When will the all tickets will be released?
I think I'm not sure. Maybe 1 week before. Just contact the support team. Okay.
Thank you.
I'm sorry, I joined just now. Is it right? Can I ask you?
The doubt.
No. Just the issue with that. Just now I released in the evening. I was able to review all of the thing, all the extra activity. But in
Hmm.
one case, it was showing 404 error. But I'm not sure if it's a technical glitch with the IIT side or from the website
The
is.
peer review has been resolved. Like they have resolved the issue. So maybe it is from your side, I guess.
For the
No,
reviewers,
no,
they
the
could find that
407 error is a server research.
the reviewers could find that they are some having a problem of opening the Google spreadsheet.
No, that's not the issue here. It shows the server. It's not connecting to the server. 404
So just
error.
refresh it once again, I guess. Just refresh it.
Okay, I'll try that
Yeah,
because I
just
tried
try it.
that more than once.
Yeah, just try
Okay,
it. Or if
thank you.
it's not happening, just contact the support team again.
Okay.
Because I contacted many were having this issue, right? So I contacted yesterday only. So they have resolved.
Okay.
They told me that they have resolved, and I checked with the students. So they said that has
Okay.
been resolved. So just check
Okay.
it once again, and if
Okay.
not, then just contact support team.
Okay. The other thing is like in my case, the extra activity, for my thing, all the 5 reviews have been done. But in the second extra activity, still one review is pending.
Okay, yeah, they will because it was not working, right? So maybe let's wait.
Are they planning to extend the date?
No, no, today is the last date only. Let's wait. Let's see if people will do it.
Okay. Okay. Okay.
Okay,
Thank you.
Tara. Yeah.
Then
Mhm,
I
then
got
the question. Which
then
question will be answer the question? Then the question. So see, this is from the activity questions, right? So he's having 12 questions. Each question is having four choices. If he answers the question, then find the number. He can attempt the entire question paper, right? So for the first question, there is five choices, right? So for all the 12 questions, we are having five choices. What are the five choices? Five choices in the sense, for the first question, I'm having four choices, right? So he can opt for first option, second option, third option, fourth option, or fifth option is he will not attempt that question. So for each of the questions, I'm having five choices. So similarly, that for what first question, I'm having five choices. For the second question, I'm having five choices. For the third question, I'm having five choices. So like that, and for 12 question, I'm having five choices. So it will be sorry, 5 raised to the power 12, correct?
one raised to power 5, is it?
So what?
One raised to one raised to the power 5, is it?
For the first question, I'm having five choices. For the second, I'm having five. So in total, I'm having 12 questions. Each of the 12 questions, each of the questions, I'm having five choices. So how many possible ways we can attempt the question? 5 raised to the power? No, just a second. Each of the question. Well, for each question, there are four choices. If you answer the question, then you find the number, attempt the question. Okay, just a second. Four choices if you answer the question. Number people.
Ma'am, for every question there would be like four choices. So then it would be 4 into 4 into 4, like that 12 questions. So I think it's like 4 raised to 12. It's
But
not
that
412.
is,
I think.
no, that is, I'll just see this question. Mm. Tara, I'll just, in the next session, I'll just do this question, okay? I'll just solve it and let you know. Fine? Okay, Tara?
Okay, ma'am.
Yeah.
Okay. Oh,
Mhm. Okay then. So I guess that's it. Shall we end the meet now? If nobody is having any doubts. So for Anne, I'll just do the question next session and for Tara as well. Okay?
okay, ma'am.
Okay.
One
Okay
more.
then. Bye. Bye everyone. Thank you.